Okay, today as we move into the next unit, we're going to begin with a discussion of the 5 basic laws of exponents. There are 5 of them. None of them are any more important than any of the others. You have to know all 5 of them pretty much in order to stand a chance of working on the type of problems that we're going to be working on this unit. So absolutely take notes. You're going to need to write these down. You're going to be referring back to these notes over and over again, and hopefully it won't take long before you get these 5 rules kind of burned into your memory, and then you'll have them forever. So let's take a look. Well, if my board will respond. Here we go. Okay, before we get going here, we're going to make sure that we understand exactly what it is that an exponent is, what it is that it's saying. What does it mean when they raise something to a power? Like if they say something is squared, x squared. What is it that they actually just said? Okay. Okay, double. And that's one of the things that I heard in 2 different locations here. Double. What does it mean when we say to double something? Multiply. Well, double particularly means to multiply something by 2, right? If you had a $20 bill and I doubled your money, I would be giving you another $20 bill. So you'd have a 20 times 2. But an exponent, and somebody began to understand, to catch this, okay, when you multiply or square something, it's not that you multiply it by 2, it's that you multiply it by itself. So if I gave you a $20 bill and asked you, would you want it to be doubled or would you want it to be squared? Those are 2 entirely different questions with 2 massively different outcomes. Because if I double your $20 bill, it just went to 40 bucks. If I square your $20 bill, which is 20 times another 20, it just went to 400. Okay, so it's an enormous difference. Okay, so it's very important for us to understand that when we are dealing with exponents, there is an enormous difference between x to the 7th power, which means to multiply x times itself 7 times. Okay, x times itself 7 times. The common mistake, which is what the mistake that was just made in the classroom right when we got started, the common mistake would be to say, okay, what is x to the 7th? To just take a 7 and multiply it by x, and that is absolutely positively not the way this works. Okay, so when you raise something to an exponent, it's not just multiplying by whatever number the exponent is. It's to multiply this base, like x up here, multiply it times itself, however many times the exponent says to multiply by itself. Okay, that's a critical difference, and this is something that has caused students problems on TAKS and TOS and will continue to cause people problems on end of course because we don't understand this one simple rule, and we've absolutely got to get it. Okay. Now, as I said, there's 5 laws that we're going to have to work with, and we are going to have to remember them. Okay, when we're working with exponents, there is no getting around it. I don't have any cutesy ways of remembering any of this stuff. It's just cold, hard facts, and you're going to have to spend a little bit of time looking at it until you get it memorized. So let's take a look. Okay, the first law, and write this down. Okay, the first law deals with the situation where we are multiplying 2 bases that are the same. And by bases, what I mean is you have a base, which like in this little example here is x, and then you have an exponent, which is n, and that is being multiplied by another base, which is also x, being raised to some exponent m. So the bases are the same, x times x. When this happens, okay, when you have a base times the same base, the rule is for you to add the exponents together. Okay, you're just going to have to learn this rule. The tendency is people want to try to multiply the exponents. Why do they want to try to multiply the exponents? Because the problem has a multiplication sign in it. But you've got to program your brain to override that. When the bases are the same and the bases are being multiplied, it is not a multiplication problem. The exponents are going to want to add together. So if you want to see that in a more numerical type of example, let's look at this one. X to the third times x to the fourth. Okay? What type of math do you do here? The bases are the same. X times x. What type of math is happening with the exponents? Add them up. Okay, it's that easy. So what's our answer going to be here? X to the third times x to the fourth. What's it going to be? X to the seventh. Exactly. The number one incorrect answer. If they throw something this simple at us on our end of year tests, X to the 12th will be an answer choice. And it will be massively picked because people see that multiplication sign and they're going to want to multiply those exponents. Your brain's got to overpower that. You've got to understand that when it's the same base being multiplied, it's actually addition between those exponents. Okay? That's law number one. All right, law number two. Law number two deals with the situation where we have two bases that are the same, just like we had with law one. Only this time, instead of being multiplied, we're dividing. This rule's a little bit more complicated to learn, okay, but again, once you just get it memorized, it will become common for you. But the rule basically says if you have two bases that are the same, x divided by x, like you see right there, then the rule says what you're going to do is we are going to subtract the exponents. Okay? We're going to subtract the exponents. And the order of that subtraction is always going to be whatever the numerator's exponent is minus whatever the denominator's exponent is. This can do a few things to us. When we do that subtraction, it can actually cause a positive number, positive result, okay, which we'll talk about what happens then. It can also give us a negative exponent, which causes a different type of a problem, and we'll get to another law here in just a second that deals with that. And it can also cause a zero for an exponent, which is another law, and we'll deal with that one here in just a second as well. Now, after you do law 2 and you do the numerator's exponent minus the denominator's exponent, okay, your answer isn't going to be a fraction anymore, at least temporarily. Okay, and I'll show you what I mean by that here in a few moments. Okay, but if you're dividing the same variable, take the numerator's exponent minus the denominator's exponent, the answer is no longer going to be a fraction. Okay, so let's take a look at an example that deals with this situation. Here we have x to the fifth being divided by x squared. When you look at the problem, you need to notice that the bases are the same, x divided by x. Okay, when this happens, when it's the same base, okay, we follow law 2. Law 2 says to take the numerator's exponent and subtract the denominator's exponent. Top minus bottom. Okay, so what's top minus bottom? 5 minus 2. Obviously, is going to be a 3. And again, this is possible you'll get a positive exponent. It's possible you'll get a negative exponent. It's possible your exponent might be 0. We'll deal with those situations here momentarily. Okay, and I'll tell you what, I mean, if a question like this shows up, okay, end of year tests, the most number one incorrect answer is going to be x to the 2.5 or 2.5. Okay, and that's, I mean, that's just because people are going to see that division and they're going to think, hey, divide means divide. Yes, it does, as long as you're talking about numbers. But if you're talking about exponents, it is a subtraction problem between the exponents. All right, law 3. Law 3 is the only situation where we ever get to multiply exponents. And that only happens in the situation where we have an exponent raised to another exponent. Okay, a power raised to a power. That's a multiplication problem. Like I said back when we were talking about Law 1, everybody always wants to multiply on Law 1 when they see that multiplication sign. You don't get to multiply in Law 1, you got to add. But you do get to multiply in Law 3. Exponent raised to an exponent is going to multiply the two exponents. Okay, this one's pretty easy to understand. Let's look at this little example here real quick. Let's say we have x to the third, which is then raised to the seventh. Okay, so on a problem like this one, you need to recognize that we have something being raised to a power, which is then raised to another power. Okay, this is a multiplication issue. Okay, so we've got x to the 3 times 7. What's 3 times 7? 21. There you go. Okay, so this is x to the 21st power. Okay, law 4. Okay, when we were talking about law 2 and we were doing the subtraction of the numerator minus the denominator, we said it's possible we might end up with a negative exponent, which is exactly true. Okay, but it's also possible that we may have problems that have negative exponents in them before we even get our hands on the problem. Well, it's considered bad format to leave a negative exponent in a problem. So whenever you come across a negative exponent, we are going to have to deal with that negative exponent before we will be done with our problem. And here's basically the deal. If you ever run across a negative exponent, what that exponent is saying is that that base is in the wrong position in the fraction. Okay, there's only two places things can exist in a fraction, either in the numerator or the denominator. If you find a negative exponent and that thing is in the numerator, that negative exponent is telling you that it's not supposed to be in the numerator, it's supposed to be in the denominator. And vice versa. If you have something in the denominator that's got a negative exponent, that's saying it's not supposed to be in the denominator, it's supposed to be in the numerator. Okay, so what happens is, okay, as the rule says, if you raise a variable to a negative exponent, the negative part of the exponent does what we call reciprocates. Okay, and we've talked about reciprocates before. Remember what it means to reciprocate something? Flips it upside down. Okay, it flips it upside down. So if we have something that has a negative exponent, then what's going to happen is that thing's going to have to flip. If it's in the numerator, it's going to have to go to the denominator. And if it's in the denominator, it's going to have to go to the numerator. But when it does that, that takes the negative part of the exponent, takes it away. Okay, so like in this case, this is an x to the negative n. That's in the numerator. Okay, so putting it down into the denominator takes the negative part of the exponent away, and it becomes x to the positive n. Okay, we're going to look at a couple of examples like on this because it is a little bit more complicated than some of the other rules. Okay, let's start with something pretty simple, like x to the negative fourth. Okay. Well, x to the negative fourth is not simplified because we don't like negative exponents in our answers. Okay, so what that's saying is x is currently in the wrong place in the fraction. Okay, well, where is x in the fraction? It is in the numerator, denominator, or what? Okay, well, what does it mean if something's not written as a fraction at all? Like this is, it's not written like a fraction. Okay. Okay, what's actually, when something's not written as a fraction, that is automatically in the numerator. What's in the denominator underneath it? Yeah, a 1. Okay, everything is a fraction, even if it's not written as a fraction. If they don't put anything underneath it, then it's automatically 1. Okay, so this is x to the negative fourth over 1. But the negative exponent is telling us, hey, x is not in the right place. Okay, so x to the negative fourth doesn't belong in the numerator. It belongs in the denominator. So we're going to send it to the denominator. In the process of sending it to the denominator, the negative 4 is going to become positive 4. and it will be in the denominator. And that is what has happened here. Now, when we say it reciprocates, it doesn't mean that we flip the entire fraction, because it's actually possible we may not be flipping more than just one thing in the fraction. And we'll get to some more examples of that here in just a second. Let's look at one more basic one. Well, here's one that's got a little bit of extra clutter in it. We've got 2 over 3x to the negative 2. Okay. Well, the negative exponent on that x is telling us that x is not in the right place. Okay, so we're going to have to move the x. Now, before we start throwing things all over the place and flipping things upside down, let's look at this one particular term at a time. 2 in the numerator. Does it have a negative exponent? It doesn't. So is it going to jump to the denominator? No, it's going to stay exactly where it is. It has a positive exponent. It's 2 to the positive 1. If it's got a positive exponent, then it is exactly where it's supposed to be. It's not going anywhere. How about this 3 in the denominator? Does it have a negative exponent on it? Okay, well, what is its exponent? Positive 1, right? 3 to the first. It's not 3 squared or 3 cubed or 3 to the fourth. It's just 3. Okay, so it doesn't have a negative exponent either. So it's not going anywhere. It's going to stay in the denominator. But x does have a negative exponent. So x is going to move. 2 is going to stay put in the numerator. 3 is going to stay put in the denominator. But x is going to be on the move. Where is it going? It's going out of the denominator up to the numerator. In the process, the negative 2 will become a positive 2. So what will you now have in the numerator? The 2 that's already up there. The x is coming up to join it, so there'll be an x squared. In the numerator, we'll have 2x squared. What will be in the denominator? That 3 did not leave. It did not have a negative exponent, so it stayed exactly where it was. Okay, so with law 4, it is very possible. Okay, and matter of fact, most of the time, that's the way this is going to work. Certain parts of the numerator and certain parts of the denominator will be passing through the fraction bar. Things will be jumping up, things will be jumping down, but other things are going to end up staying put. It all depends on whether they have positive exponents or negative exponents. Okay, we'll get some more practice with law 4 here when we get to some more in-depth examples. The last law, law 5, also, when we were talking about law 2, we said the possibility of when we did that subtraction, we might end up with a 0 power. This is kind of a strange law, and it's honestly, it's too hard for me to even explain why this is. So I'm just going to kind of leave it at, this is the rule. Trust me that it works this way. Okay, maybe someday, a few years down the line, you'll have a class that'll kind of talk to you about it and why it is this way. But for right now, just understand that anything to the 0 power results in a 1. Just a 1. No variables, nothing crazy or anything like that. Anything raised to the 0 power is the number 1. Okay, so strictly speaking, we could take a value like 5 and raise it to the 0 power. Okay, well, law 5 says anything to the 0 power is 1. That's kind of a strange thing to think about because we just took a 5 and turned it to a 1. Okay, well, that's a little strange, but that's just the way that it is. Okay, and the same goes for anything. Here, I took 5x, y squared, z, took the whole thing, raised it to the 0 power. What's anything to the 0 power? 1. Okay, that's simply the way that it is. All right, so those are the 5 laws. Okay, now here's some basic strategy or ways to think. So you can jot this down if you want. I'm going to go through it kind of quickly. If you need it more, you can look it up on Edmodi later. Okay, but basic ways to think about exponents. Okay, the laws of exponents apply any time that the order of operations allows exponents to be considered. So any problem, any time. When you get to please excuse my dear Aunt Sally and it's time to think about parentheses and exponents, okay, well, these are the rules that we're thinking about exponents by. Okay, so if any of the 5 laws happen to show up when it's time to do parentheses and exponents in order of operations, do them. Okay. Secondly, There is no order of operations within the laws themselves. Okay, the laws are ordered. Law 1, Law 2, Law 3, Law 4, Law 5. That doesn't mean that you go about them in order. You got to do Law 1 before Law 2, and you got to do Law 2 before Law 3. That's not what that means at all. Okay, they're simply 5 laws. They're in no particular order. So anytime you have any problem that uses any of the laws of operations and it's time to, or the laws of exponents, and it's time to look at exponents, hit them. Okay, it doesn't matter what order you see those laws in, just get after them. Okay, the third rule here, the third little guideline, the laws may be used repeatedly in the same problem. What that means is you may start off a problem doing law 1. And that's the way a lot of people choose to. They like to do law 1 first, and that's fine. But that doesn't mean when you finish law 1 that law 1 might not show back up again in the exact same problem. So if you need law 1 9 different times in a problem, then just keep on hammering on it until you finally get the problem finished. And lastly, the laws rarely operate independently of one another. Usually the type of problems that we see, if there is one of the laws of exponents, there's probably more than one of them there also. Very rarely we just get to work on like law 3 and that's all. Usually there's 5 of them. The problems we see usually use 2, 3, 4, sometimes even all 5 of the different laws before we actually get done with the problem. Okay, so let's take a look at some more in-depth type of problems and see if we can't figure out what they're doing. As you can very easily visually notice on this problem, there's more than one step going on. This is more complicated than any of the examples that we saw going through the 5 laws. Okay, but trust me, this is not as complicated as the problems are going to be. Okay, typically on tax, and I assume on STAR, question number 1 on those tests is almost always a laws of exponents problem, and they've got a whole bunch of stuff tangled up in it. Okay, but let's take a look here. Okay, well, let's look at the problem. Okay, first thing you notice, 2 different bases. We've got some x's and we've got some y's. Well, one of the things you've got to remember with the laws of exponents, all of them deal with being the same base. X's apply to other x's, y's apply to other y's. So we won't be doing any crazy math that somehow takes x's and y's and binds them into turning into z's or some other crazy thing. Okay, x's go to other x's, y's go to other y's. Well, look at the numerator. Okay, what do you see in the numerator? X's. Okay, but do you see any particular law going on with those X's? Yeah. How about law 1? Right, we have an X times an X. Okay. Well, what's the rule with that? What are we supposed to do when we have X times X? Add them up. Okay, so what do you actually have in the numerator? We have X, and then we're going to have 2 plus 3 in the numerator. What's going on in the denominator? Yeah, we got y's in the denominator. Do you see any particular law operating on the y's? Yeah, law 1 again. We've got y times another y. So once again, that is an addition problem. 1 plus 2. And very easily, you can see that in the numerator, 2 plus 3 is 5, and 1 plus 2 is 3. This x and this y will never combine. Okay, they're never going to join together to make some other thing or anything like that. We've got all the x's in one place. We've got all the y's in one place. We have no negative exponents or anything like that. Our problem is done. Okay, that's all that it takes. All right, let's look at a different one. Once again, before you get going, you probably want to notice that some of the information is x's and some of the information is y's. Okay, it's important to notice that because we don't want to accidentally combine the x's and the y's into trying to be just one variable. Okay, well, look at the x's there on the left. Okay, you see any particular law going on around the x's there? How about law 3? Do we have an exponent raised to another exponent? Yes, we do. Okay, so what's the rule? What do you do when you have an exponent raised to another exponent? You multiply, exactly. So x is going to eventually be raised to the 3 times 4 power. And what's happening with the y's? Same thing. We've got law 3, exponent raised to an exponent. So y is going to be raised to the negative 2 times 3. Okay, so what power is x raised to here? 12. And what power is y raised to? Negative 6. Okay. We've got all our x's in one place, which is good. We've got all our y's in one place, which is good. There is one thing that is still bad in the problem. What's bad in the problem? Negative exponent. We're not allowed to leave this thing like that. Okay, so how are we going to get the negative exponent to turn into a positive exponent for us? Yeah, y needs to be reciprocated. Okay, if it's in the numerator, it needs to go to the denominator. If it's in the denominator, it needs to go to the numerator. So where is it right now? It's in the numerator, right? Because there's no denominator underneath it. So it's automatically in the numerator. So that means that we are going to end up with a fraction. Okay? So y, we've already decided, is going out of the numerator into the denominator. What's its exponent going to be? Negative 6 is going to become positive 6. Okay, by going through the fraction bar from the numerator to the denominator, it's like the fraction bar steals the negative sign away from the exponent. Okay, how about x to the 12th? Where will it be? Is it still in the numerator? Does it go to the denominator with y? What happens? Stays in the numerator. Why did it not leave the numerator? Because its exponent was not negative, so it was okay in the numerator. All right, there we go. Let's look at one more. This is probably more to the difficulty level of a question that you might see on an end of course or tax test at the end of the year, as far as just a straightforward question that is examining your ability to look at the laws of exponents. On these questions, it would not surprise me at all to see several variables, which is what we're seeing here, positive and negative exponents, which is what we are seeing. It's a rational expression, meaning we have stuff in the numerator and stuff in the denominator, which is what we're seeing here. And it certainly wouldn't surprise me to see a 0 power pop up either. Okay, so let's see what we can do. The first best strategy on problems like this, where it's got all these different variables, is to combine the variables as best you can. Okay, right off the bat. Don't really worry about getting things from numerator to denominator or anything like that. Just look at the numerator. Let's see what we can combine. Look at the denominator. Let's see what we can combine. And then look at the problem again. We'll have a look at the numerator. Is there anything we can combine? I see law 1 on the x's. Okay, you see up there that you have x times x times x. There's no reason for all those x's to be written separated like that. So let's look at combining the x's. What will the exponent of x be? Okay, well, how do these combine? X times x times x. What kind of math is going on with those exponents? It's addition. 1 plus 3 plus negative 4. How about that z up there? Does z have anybody to combine with in the numerator? Yeah, not right now. Okay, so we'll just write the z down. He'll wait a little while and see if we can't find anybody to combine with in the denominator here in a little while. And the denominator does not have y's in too many places, only one place, and it doesn't have z's in too many places, just one place there also. Okay, so let's see what we've got. How many x's are there? What is it? X to what power? 1 plus 3 plus negative 4. What is this? It's 0. So we have x to the 0 power in the numerator. We have z to the first power in the numerator. We have y to the negative 2 in the denominator, and we have z to the 2 in the denominator. Okay. What do you see now? See anything you can tackle here? How about right off the bat? X to the 0. What's x to the 0? It's 1. So it is x to the 0. Is it even going to be written down anymore? It is not. In the next step, okay, in the next step, x to the 0 is going to be gone. Okay, it's just a 1. So we're going to end up with z to the first. Okay, how about this y to the negative 2 that's in the denominator? Okay, can we clear up this negative exponent problem? Yeah. It's got a negative exponent in the denominator. What does that mean? It means that y does not belong in the denominator. So what are we going to do with it? Send it up to the numerator. In the process, the negative 2 will become a positive 2. And there's still a z squared in the denominator. Okay. One more thing that I see, we still have z's in the numerator, z's in the denominator. Okay, we're supposed to get all our variables in one spot. We got z's in two spots. Okay, so how does that work when you have z's in the numerator and z's in the denominator? Okay, what kind of math goes on with their exponents? Law 2, subtraction. Okay, the numerator, okay, come over here, I'm going to put z, the numerator's power, which is 1, we're going to subtract from it the denominator's power, which is negative 2. That's going to equal what? Z to the negative 1. And we said the answer is no longer going to be a fraction. Okay, no longer going to be a fraction. That's going to put this z to the negative 1. It's going to put it in the numerator for us. Okay, so let's see what we got now. We already have y squared in the numerator. Now we have this z to the negative 1 in the numerator. There's nothing left in the denominator right now. At least temporarily there's not, because look what we ended up with. Z to the negative 1 power. What does that mean? Z is currently in the numerator, and it doesn't belong there. It belongs back in the denominator. So here comes the fraction back. Y squared is in the numerator. Z to the positive first is in the denominator. The x's are all in one place. They happen to eliminate themselves. The y's are all in one place. The z's are all in one place. We don't have any negative exponents. We don't have any zero exponents. We have done the laws of exponents as far as we can do them. There's nothing else we can do to the problem anymore. This is the answer. Okay, and my bet would be that on a test, end of year test, they're going to engineer a problem that's going to start off kind of like this one. It may have 5 or 6 different variables in different spots, and you're going to have to use the laws of exponents in a whole bunch of different ways, and you'll end up with an answer that's really not all that complicated. It's just going to take several steps to combine everything that they've got that needs to be combined. Okay, it's going to take a little bit of getting used to, so we're going to have to get those laws memorized and practice how these problems work. So there's an assignment. Let's get to it.